All right, so 5.4, day 1. It starts with a warm-up, and it's find the sum or difference. So it's basically add and subtract these fractions, right? So this is meant to, like, basically when we start getting on the notes, it explains what we're doing, okay? So go ahead and pause the video, just add these fractions. All right, so in order to add two fractions, you need a common denominator. The least common denominator for 4 and 3 is 12, so I'm going to make them both 12ths. The first fraction I'd have to multiply by 3 over 3, so this becomes 3 pi. The second one, 4 over 4, so this becomes 4 pi, so that's 7 pi over 12. Okay. All right, next one here, common denominator is 12 again. All right, first fraction I'd have to multiply by 4 over 4, so that's 8 pi. Second, I'd have to multiply by 3 over 3, so that's 3 pi. So this is 11 pi over 12. All right, here I have pi over 6 and pi over 4. The least common denominator is 12 again, not 24. So it's not always the 2 multiplied. Multiply by 2 over 2. Multiply by 3 over 3. And you get 5 pi over 12. So if you're like, well, I got 24, but then you had 10 pi over 24, which simplifies to 5 pi over 12. So faster to get the least common denominator. D is very similar to A if you look, right? But it's subtraction. So what I'm going to do is I'm just going to hit copy, and I'm going to hit paste over here. And then I'm going to change this to subtraction. And then that's negative 1 pi over 12. And then this one, pi is not a fraction, so I'm going to put it over 1 to make it a fraction. And now I can see my least common denominator is 6. I'd have to multiply my first fraction by 6 over 6. This becomes 6 pi over 6. And then this one already has that, so 7 pi over 6. Okay? So adding fractions, not hard at all. What we're going to be doing is now we are going to be given this. And we want 2 angles from the unit circle that add to it, okay? So we know that these 2 things add to it, so then we can get these 2 angles, right? We are going to be given this, and then I need 2 units from the unit circle that add to 7 pi over 4. 7 pi over 12. 4 pi over 4 and pi over 3 add to 7 pi over 12. So we basically have to think backwards to get to this, okay? All right, so before we start, we need to know, if you scan ahead, we have 6 formulas that you need to know. Okay, so these are 6 formulas that you need to know. The first one, or the first 2 are the cosine. There's sum and difference formulas, and this one's for cosine. They're very similar, so if you know the first one, you know the second one, okay? So I think of them as patterns. Cosine's expansion goes cosine, cosine, sine, sine, cosine, cosine, sine, sine. And whatever this sign is, you change. Okay, so I'm going to write it and then show you my pattern I'm talking about. So it goes cosine, cosine. So cosine of alpha times cosine of beta, cosine, cosine. Whatever this sign is right here, you change it, so minus. And then sine, 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 and then alpha, beta again. Alpha, sine of beta. And that's the formula for it. Okay, so if I have the cosine of alpha plus beta, I could expand that to cosine of alpha times cosine of beta minus sine of alpha minus sine of beta. I remembered it as cosine, cosine, sine, sine, change the sign. So if I do the same thing here, it's cosine, cosine, so cosine of alpha, cosine of beta, oops. Change the sign, because that's a minus, this is a plus, sine alpha, sine beta. And those are your first 2 formulas. Not really difficult, okay? Now, I know teachers like Miss Youngman, she has a clapping, stomping dance to it. I don't. So if you want to find clever ways to remember it, you can. I think of it as my cosine, cosine, sine, sine. Okay, so let's use this formula here, okay? This one here says find the exact value of cosine of 15. So it does not mean put it in your calculator and give me a decimal answer. I want the exact value. So the first thing you should say to yourself is, I don't have that memorized from unit circle, okay? But what I can do first is do I know 2 angles from the unit circle that I add or subtract that'll give me 15? And if I think of my angles, yes, there's a couple different combinations. You can do 60 minus 45. You can do 45 minus 30. And you can do anything from the, not anything, but you can do a lot more from the second, third, fourth quadrant using those. If you can stick to the first quadrant, that's what I like to do. All right, so I'm going to do 45 minus 30. Okay. So what I want you to realize is that this is alpha now, and this is beta. Okay. That's alpha, and that's beta. So now what you're going to do, it's like cosine of alpha minus beta. You're going to expand it. Okay. So you're going to say, okay, well, this is, remember, cosine goes cosine, cosine, sine, sine, change the sign. So cosine of alpha, which is 45, cosine of beta, which is 30. Change the sign, that's a minus, so this is going to be a plus, and then sine of 45, sine of 30. Okay? It's cosine, cosine, sine, sine. So I want you to notice that. Cosine, cosine, sine, sine. I change the sign, and it's always alpha, beta, alpha, beta. On all of our formulas, it's always alpha, beta, alpha, beta. Okay, so now you can actually do this. We know the cosine of 45. We know the cosine of 30. We know the sine of 45, and we know the sine of 30. We're going to get each one of those. So it looks like I need the sine and cosine of 45 and 30. So off to the side, I'm going to do 30 degrees, 45 degrees, and I'm just going to write their ordered pairs. So 30 degrees, remember, is root 3 over 2, 1/2. 45 is root 2 over 2, root 2 over 2. And now I'm just going to replace everything that I can. So I kind of want to color code this for the first couple so that you guys know what I'm talking about. Okay, so first off, I need the cosine of 45. This is the cosine of 45. So I'm going to replace it with the root 2 over 2. I put everything in parentheses when I replace it because parentheses aren't going to hurt. Cosine of 30 I need next. Cosine of 30 is right here. So that is root 3 over 2. Then I have the plus sign. Now I need the sine of, oopsies. I need the sine of 45. Sine of 45 is right here, root 2 over 2. So notice me highlighting all this is taking extra time, so I do not suggest you do it like every time you do a problem, but for note's sake now it's good. And then last I have sine of 30. I cannot believe myself right now. Should I start the video over? Not a chance. All right, sine of 30 is 1/2. Okay. All right, color coding done. All right, so now I have this, and I just have to clean it up. So to clean it up, I need to multiply these two, and then add them. Okay? So remember, to multiply fractions, you just multiply the numerators, multiply the denominators. So root 2 times root 3 is root 6. 2 times 2 is 4. Plus, do the same thing here. Root 2 times 1 is root 2. 2 times 2 is 4. And now I have to add these. In order to add two fractions, you need a common denominator, which you already have, and then you just add the numerators. I have root 6 plus root 2 in my numerator. Realize you can't add them. You do not get root 8 from that. It's root 6 plus root 2. And there's your answer. Okay? All right, now I also want you to realize that root 2 plus root 6 is the exact same answer. If you would have used 60 minus 45, you would have gotten the answer looking like this instead, and it's the same exact thing. Okay, so please keep in mind equivalencies. All right, let's try another one with radians. So some people find this a little bit more challenging. I don't think it's that challenging, okay? All right, so I don't know the cosine of 7 pi over 12. So what I want to do is I want to change it to two angles from the unit circle that I know that when I add or subtract them, I get 7 pi over 12. So I know my common denominator is 12. And I want to start, and I know they both have pi in the numerator, so I want them to, used add because it's easy to add to 7, right? 1 and 6 adds to 7, 2 and 5, 3 and 4. So I can start by saying, okay, is it 1 pi over 12? Can I use 1 pi over 12 and 6 pi over 12? Well, 1 pi over 12, I don't know either, so why on earth would I use that? Could I use 2 pi over 12 and 5 pi over 12? 2 pi over 12 simplifies to pi over 6, so that's great. But 5 pi over 12, I don't know, and it can't simplify, so no, not you. 3 pi over 12 and 4 pi over 12 simplifies to pi over 4 and pi over 3, which I do know. So that's what I want to use. So I'm going to do cosine of pi over 4 plus pi over 3. Okay, and if you looked back here, pi over 4 plus pi over 3 is 7 pi over 12, right? So that's just to show you like, oh, yeah. Okay, we just worked backwards. All right, now I'm ready to use my sum formula for cosine. Remember, it goes cosine, cosine, sine, sine, change the sign, and it's always alpha, beta. So cosine of the first angle, cosine of the second angle. Change the sign, that's a plus, we're going to use minus, and then sine, sine. Sine of the first angle times, sine of the first angle times sine of the second angle. All right, so all 4 of these things I know, but off to the side, I like to write like the ordered pairs. I'm not going to highlight again. That took too long. I need pi over 4 and pi over 3. All right, so pi over 4 is 45 degrees, which is root 2 over 2, root 2 over 2. Pi over 3 is the same as 60 degrees, which is 1/2 root 3 over 2. Okay, so I need cosine of pi over 4, which is root 2 over 2. Times cosine of pi over 3, which is 1/2 minus, and stick your parentheses in right away if you want. Sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. Multiply these fractions. Root 2 times 1 is root 2. 2 times 2 is 4 minus. Multiply those 2 fractions, you get root 6 over 4. Subtract those fractions. You need a common denominator, which you already have. And then your numerator is root 2 minus root 6. And there's your answer. Okay? Now I also want you to realize if you would have said pi over 3 plus pi over 4, you would have gotten negative root 6 plus positive root 2 over 4, which is the exact same answer. So please make sure you're able to read your answer and know that yours is still right if it doesn't look exactly like mine. Okay, I don't know why I erased that. It was unnecessary to erase it. All right, next we need our sine sum and difference formulas, okay? All right, so I like to think of sine formulas as like it's a sandwich with sine bread and cosine meat. So it goes sine, cosine, cosine, sine. You keep the sine, but it's still alpha, beta. Now you might be saying, what? I'll write it, and then I'll explain how I remember it. So it goes sine of alpha, cosine of beta, keep the sign, so plus, cosine of alpha, sine of beta. So if you look at it, it has sine bread, right? Cosine meat. I kept the sign, and it's still alpha, beta, alpha, beta. All right, same thing here. Sine of alpha, cosine of beta. Keep the sign, so minus. Cosine of alpha, sine of beta. Oh, that's an ugly B. That's okay. All right, so I just thought of something and now I can't remember. All right, let's just move on since I was going to say something and I can't remember it. All right, so once again, this formula here, cosines is cosine, cosine, sine, sine. Oh, that's what it was. Cosine's formula is cosine, cosine, sine, sine, change the sign. Cosine starts with the C, change starts with the C. Sine formula is sine, cosine, cosine, sine. Keep the sign. Keep the sign for sine. Okay, was that confusing? Let's hope not. All right, find the exact value of sine of 11 pi over 6. I don't know, I don't have it memorized, but I can break it up into 2 angles that I do know. Now remember, there can be multiple answers here, so I start by unsimplified fractions to get my numbers rolling here. Excuse me. 11 is a really high number, so I'm going to try addition. If I can't get addition, then I'll do subtraction, which I can get addition. All right, so I can start by rolling through these numbers here. I can say, all right, and they both have pi, so I can do that too. I can say, is it going to be 1 in 10? It's never going to be 1 in something because the 1 over that shouldn't be simplifiable, right? Okay, I shouldn't say never, but I can't think of a circumstance. All right, can I do 2 and 9? I could do 2 and 9 if I want. I could do 3 and 8. Those all simplified as stuff on the unit circle, which is good, okay? Now, usually when I open up to the class, the first example people come up with are 3 and 8, so I'm going to do that. And if you did 2 and 9, that's fine too. Sine of This is pi over 4 plus, and then this simplifies. 4 goes in there twice, and 4 goes in there 3 times. Okay, so now I'm going to use my expansion. Sine goes sine, cosine, cosine, sine, keep the sine. So sine of the first angle, cosine of the second angle, keep the sine, cosine, sine, cosine of the first angle, sine of the second angle. All right, so I'm going to need pi over 4 and 2 pi over 3. So off to the side, I just like to write those down. So pi over 4, 2 pi over 3. All right, pi over 4 is root 2 over 2, root 2 over 2. And then 2 pi over 3, it's a pi over 3 angle, so it's 60 degrees, 1/2 root 3 over 2. But 2 pi over 3 is in the second quadrant, so it's left and up. All right, so now I'm going to replace. Sine of pi over 4 is root 2 over 2. I'm going to put my 4 sets of parentheses in. Makes me happy. All right, cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. Cosine of pi over 4 is root 2 over 2. Sine of 2 pi over 3 is root 3 over 2. All right, clean this up. This is root 2 times negative 1, which is negative root 2. 2 times 2 is 4. You want the negative in the numerator because then it makes a negative 4 in your denominator, and then you don't have a common denominator. It's just silly. Plus, and then root 2 times root 3 is root 6 over 4. So I get negative 2 plus, negative root 2 plus root 6 all over 4. There's your answer. Also remember root 6 minus root 2 all over 4 is the same answer. Okay. All right, next one. Find the exact value of cosecant of 105. So first off, cosecant, I get a little nervous because I'm not comfortable with that. So what I'm going to do is I'm not going to change it because I can't change it to sine of the reciprocal. I can't change it to its reciprocal and be 1 over 105 because that's insane. So what I'm going to do instead is I'm going to pretend that it says sine of 105. Okay? But I know that sine of 105 and cosecant of 105, they are reciprocals, so when I'm done, I can take the reciprocal. Right? So find sine of 105 and take the reciprocal. All right. So I'm going to do sine of 105. And I'm going to say, okay, I don't know the sine of 105, so I'm going to break it into 2 numbers. I feel like it's going to be easy to find 2 numbers that add to 105. So a lot of times people just wait for me, and they're just like, okay, what is it? So if you don't know, like we're using 30, 45, or 60, and then we can go into the second quadrant if we need to, but I like to start off with those. So if I start by saying 30 plus what? It's 30 plus, what is that, 75? And I don't know 75, so no, it's not. I'm not going to use 30. So then I'll say, okay, 45. 45 plus what gives me 105? And I say, oh, 45 plus 60 is 105. So boom, 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 right? So I'm going to need 45 degrees and 60 degrees. Root 2 over 2. Root 2 over 2. 1/2. Root 3 over 2. Okay. All right, so this is sine. So it goes sine, cosine, cosine, sine. Keep the sine. Sine of 45. Cosine of 60. Keep the sine. Cosine, sine. So cosine of 45. Sine of 60. A quick check before you go and do this is make sure it's sine, cosine, cosine, sine, alpha, beta, alpha, beta. All right, now I can replace 4 things. 1, 2, plus 3, 4. Root 2 over 2, 1/2. Root 2 over 2, root 3 over 2. All right, and now I'm going to multiply. Root 2 over 4 plus root 6 over 4, which is root 2 plus root 6 over 4. So this is sine of 105. Remember, I want cosecant of 105, which is the reciprocal. So I have to flip this answer. It's 4 over root 2 plus root 6. And we're not going to make you rationalize that. We're going to let you leave it like that. Okay. Last but not least, we have tangent. Okay. So tangent's formula looks like this. Okay. So first off, it's a fraction. It's the first thing I do to remember it. The numerator is like if you distributed the word tangent to each of those. Okay, so it's tangent alpha plus tangent beta. That's the numerator. The denominator is 1, and then this sign's different. So if that's plus, it's minus. And then these two multiplied. So tangent alpha times tangent beta. Okay. So if you do this one, it's a fraction, and it's like distributing the tangent. So tangent of alpha minus tangent of beta. And then 1, the opposite of this. So plus, I said it was supposed to be the opposite, and I didn't take the opposite on this one. So minus, just happened to notice that. Take the opposite, so plus, and then multiply those two. Tangent of alpha times tangent of beta. Okay. All right, so just 2 more examples with tangent, and then we'll go backwards. Okay, so this is find the exact value of tangent of 75. So I have tangent of, I don't know 75, so I'm going to break it. So I can start with 30 and say 30 plus what gives me 75? 30 plus 45. And if I couldn't figure 30, then I can move on to 45, but 30 and 45 go in there. Okay. So now I'm going to use my formula. So remember, it's like distributing your tangent. So tangent of 30 plus tangent of 45 divided by. And then I'm going to do 1 opposite of that sign, so minus, and those two multiplied. Tangent of 30 times tangent of 45. All right, now I have to replace. So I need to know tangent of 30. And I need to know the tangent of 45. Remember, it's tangent. Okay, so tangent of 30 is root 3 over 3. Tangent of 45 is 1. So I'm going to go through and replace. Okay, so going through and replacing, I have tangent of 30. Tangent of 30 is root 3 over 3. Then I have plus. Tangent of 45 is 1 divided by 1 minus tangent of 30, which is 1. This is 1 times tangent of 30 is not 1. Tangent of 30 is root 3 over 3. This is root 3 over 3 times 1, which is root 3 over 3. Okay. Now I have fractions with inside fractions, so I have to clean them up. It's not allowed here, so I need to clean up my numerator. So I need to get a common denominator, which is 3. So this is going to become, this is 1 over 1, which becomes times 3 times 3. So I'm going to say times 3, or I'm going to make them both 3 right now, not times 3. I'll just not skip any steps so I don't lose any one. So this is still root 3, and I would have to times 3 on this one. So this new numerator becomes root 3 plus 3 all over 3. And now I need to do the same thing to the denominator. I need a common denominator, which is 3. So I'm going to do 3 and 3. A minus there. This would be 3 over 3. This would be root 3 over 3. So this new fraction is 3 minus root 3 over 3. So now you have this as an answer, which is just horrific looking. So what I'm going to do is I'm going to do this divided by this. I'm going to 3rd grade math it. Root 3 plus 3 over 3 divided by 3 minus root 3 over 3. And remember, I don't divide fractions, so I'm going to multiply by the reciprocal. So I'm going to change this to multiplication, and I'm going to flip that. So I'm going to do times 3 over 3 minus root 3. The factor of 3 cancels here, and my final answer is root 3 plus 3 over 3 minus root 3, which is not simplifiable. Well, it is, but we're going to leave it like that. But nothing cancels is what I should say, because this is a factor, this is a factor. Okay. Last one, find the exact value of cotangent of pi over 6. I don't know cotangent of pi over 6. I also don't want to do it with cotangent, I'm going to pretend it says tangent because I don't have a formula for cotangent either. I forgot that mess, right? So I'm going to pretend it says tangent of pi over 12, and then I'm going to do the reciprocal. Sip. Okay, so I'm going to pretend it says tangent of pi over 12. Tangent. So I need two numbers that add or subtract to give me pi over 12. 1 pi over 12 is really small, so I'm going to use subtraction because I can't think of two numbers that add to give me 1, right? Okay, so subtraction. So I can start by saying like 3 pi over 12, 2 pi over 12. That works. 4 pi over 12, 3 pi over 12. That works. I can do a bunch of different things. So I'm going to stick with that 4 pi over 12 and 3 pi over 12. So I have tangent of pi over 3 minus pi over 4. And now I'm going to use my tangent formula. So I need tangent of pi over 3, which is root 3. And then I need tangent of pi over 4, which is 1. Okay, so now I'm going to use my tangent formula. So it's like distributing the tangent of pi over 3 minus tangent of pi over 4 over 1, change the sign plus, and multiply those two. Tangent of pi over 3 times tangent of pi over 4. Okay, so now I'm going to replace tangent of pi over 3, root 3, minus tangent of pi over 4, 1, over 1 plus. Tangent of pi over 3 times tangent of pi over 4 I do in my head because it's root 3 times 1, which is just root 3. This has no fractions in it. It's done. Moral of the story, try to get 60-degree reference angles. It's easier. Okay, last but not least, find the exact value of each expression. So first thing people want to say is, oh, I can use cofunctions. 20 plus 10 is not 90, so you can't use cofunctions. But what you should notice is that this alpha, beta is the same as this right here. If I call this alpha and beta, it's two different angles. It's alpha, beta, and it's sine, cosine, cosine, sine. So which of my sum and difference formulas goes sine, cosine, cosine, sine? That's your sine formula, and it's sine of, and then sine, you keep the sign, alpha plus beta, 20 plus 10. So you're basically working backwards, which is sine of 30. Do we know the sine of 30 degrees? Yes. The ordered pair is root 3 over 2 1/2, so this is 1/2. People like this better. All right, this one right here, it goes cosine, cosine, sine, sine, which is cosine. Remember, for cosine, you change the sign, so this is plus. Alpha is 20, beta is 25, so this is cosine of 45, which is root 2 over 2. All right, that's it for day 1.